Hey guys, welcome to Emily's Robotronics. This is your host Emily, and today we have a robot in front of you with a few sensors and few connecting wires. So that's all you can see on my desk right now. So let me just tell you what I'm gonna do now. Videos about how to make robots. We saw how simple it is to build a platform. We built this platform that you are seeing around, just that we had a big bulky battery in front, but that I got rid of that and I switched to a LiPo battery. So I have two 3.4 volts 3.7 volts LiPo battery, so combined together. This is combined in series. So both the LiPo batteries together gives about a 7.4 volts output, which will be used to drive my robot. So this is a very lightweight alternative for the robots. Just that the only thing that is challenging is charging these batteries. So you need a special type of chargers to recharge these batteries, but still it's worth the money and the size. Since its size, you can come up with very small robotic platforms and leaves a very small footprint on your complete robot. So that's about this robot. So what we're going to do today is we're going to build an obstacle detection robot. So a very simple obstacle detection robot. So we'll be following a KISS approach, where KISS stands for, where the KISS in the KISS stands for keep it simple and stupid. So what I'm going to do is I'm going to use these two obstacle sensors. So I've talked about these sensors in my previous videos. These are basically infrared based obstacle detection sensors. They emit 38 kilohertz of infrared light, which is then received by this sensor, which has a band pass filter, which filters out the signals anything apart from 38 kilohertz, and gives a true or correct detection even in presence of sunlight. So that's about these sensors. So I'm going to use a pair of these sensors as eyes for my robot. So what I'm going to do is I'm going to hook up these wires to the obstacle sensor pin here, and the corresponding connections on the robot controller board as well. And these two sensors will serve as eyes for the robot. So this will use these sensors to navigate around places. So I'm gonna build a very small, very simple program which just detects. Actually, what we have come up with a similar program, or we have implemented an algorithm for this when we were making the video tutorial for Flowcode AVR. So probably, like, if you guys want to know the algorithm involved, you can see my previous videos on the Flowcode AVR, or alternatively the algorithm involved is also mentioned in my website under robotics section for obstacle detection system. So that will give you how you can implement the code as well. So all that I'm going to show is just the hardware and hardware connections, and how the robot actually performs with the code. And I will also share a sample code that I'm going to use. So let me quickly hook up these sensors to the board. So what I'm going to do is I'm going to connect the yellow, which is for the output, the red is for the 5 volts, and the green for 0. So red for 5, green for 0 volts or ground, and yellow for the output. And I'm going to do the same thing to the other sensor as well. Green for ground, red for 5 volts, and yellow for the output. We also have a extra pin on the sensor, which is for which says disable. So we can use this pin to connect to ground to stop this sensor from generating the 78 kilohertz signal. So basically this the transmitters part of this sensor stops working, and it gives you a small amount of power saving as well. So I have these connectors all wired up. So what I'm gonna do now is I'm gonna run these wire from the bottom side of the robot. Okay, just like that. Okay, I have the wires which is run from the bottom. So yellow, I'm gonna connect it to port C bit 0, and the red wire I'm gonna connect it to the 5-volt line, which is this mid line, and the green to the ground. And I'm gonna do the same thing for the other sensor as well. I'm gonna run these wires from. So we have connected both the sensors power output to this power lines that we have here. Now we need to connect the output of the sensors to the port pins of the microcontroller board, that is our robot controller board. So what I'm going to do is I'm going to connect them to port C0 and port C1. So all the electrical connections are now made and complete, and what we need to take care of now is physically connecting these sensors to the robot chassis. So we can come up with any creative way of connecting these sensors to the chassis. You can either use two metal connectors protruding out from these two mounting holes, and you can mount your sensors on them like that. Or you can also alternatively have a connector, a mechanical component connected here, and you can place your sensors on top of that. Or any other way, any other place where you find suitable, you can come up with that and you can place your sensors. But for convenience and to make my chassis as simple as possible without using many connectors and many screws and stuff like that to hold it, I'm gonna make my robot as lightweight as possible. So what I'm gonna do is I'm gonna use a small sticky tape here, and I'm gonna mount my sensors on top of that sticky tape. One thing to note here is that we're not supposed to keep the two sensors right in parallel, so this doesn't give us maximum range for obstacle detection. So what I'm going to do is I'm going to slightly move them away so that there is a gap between them, and we have the sensors slightly positioned towards outwards. So there you see both the sensors are pointing towards opposite directions. So what this is going to do now is this is going to not just give a parallel narrow range, but this expands the range to a wider section. So you can do it that way. I'm going to stick these two sensors down there with a small angle between them. Okay, there it is. My sensors are now firmly in place, and it is ready to be programmed for obstacle detection. So there you see the top view of the robot. So we have two different sensors pointing slightly outwards to get a maximum range. So the range is gonna be, so what is gonna happen now is that the algorithm should be that when both the sensors are activated, the robot should move behind, or if one of the sensors is activated, the robot should turn away from the activated side, and the same thing applies for the other side as well. And when both the sensors are not active, we can make our robot move forward. So that's going to be the overall logic or algorithm. So we'll just quickly program the robot and see how actually this works. So in case if you feel that these wires make your robot look ugly, so you can use some wire ties or cable ties and connect them somewhere at the bottom. So you can do that. Okay, we'll just quickly program and see how this robot performs.